Hello, welcome back. So today I picked another interesting problem from LeetCode. So let's start. So let me just switch to that screen. Okay, so problem statement is farthest building you can reach. Okay, so you are given an array of heights representing the heights of building, some bricks and some ladders. You start your journey from building 0 and move to the next building by possibly using bricks or ladders. While moving from building I to building I plus 1, where the 0 indexed, if current building height is greater than or equal to the next building, you don't need any ladders or bricks. If current building height is less than the next building height, you can either use one ladder or uh, hi plus minus hi bricks. So return the farthest building index, where is the zero based indexing. You can reach if you use the given ladder and bricks optimally. So there is example and you see the image of the visualization from starting from zeroth index to uh, the last index that possibly can be reached by using the given number of bricks and ladders. So if you see the examples, inputs and explanation, so start from index 0, and if you see uh, height of second index 1 is less than, so we don't need any ladder or bricks, just to go ahead without using any we can just jump it to the lowest or equal heights. Okay, at any uh, point, if you find next height is greater than the current height, then we will be either using the ladders or the bricks. But the bricks is like will be used for the difference between both height. Okay, so that's the input, and constraint is height can be go up to 10 to power 5, and length, and similarly height length can be go to up to power 6, brick can be go to up to power 9. Okay, similarly ladders. So this is the problem. Okay, so let's understand how uh, we can approach this problem. Okay, so first thing we need to means what is target we need to get right. If you see the target, farthest farthest building we can reach using given bricks and ladders. Okay, that's the uh, index we need to find out. In this case, this is 7, means we can reach up to 7th index using 10 bricks and 2 ladders. Okay, so we will need to optimize optimally. Okay, think of, there are two conditions. If you say case 1, in case of uh, ith height, let me represent it hi, if it greater than or equal to hi plus 1, means equal or greater, then we don't need any bricks and ladder. We can just means jump into the next height building. Okay, second case where we need to optimally used up bricks and ladder. Case 2, when current height is less than the next height I plus 1. In this case, either we will be using either we will use bricks bricks or ladders. Okay, but think of, in case of we using bricks, if we utilize the bricks, then how many bricks we can use, right? Think of that will be the difference of height hi plus 1 minus hi. That what will be the diff? That diff will be used in a bricks, right? How many bricks? That the diff. And ladder can be utilized. It doesn't matter how many like difference between both heights. We can use that ladders, right? So optimally, how can we reach, how farthest we can reach optimally, if you somehow, if somehow we will utilize ladders for 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 high jump. If you say high jump, what means by high jump? High jump means max diff, max uh diff. That is the high jump, right? You making high jump, max diff of hi plus 1 minus hi. Okay, if somehow we will utilize we can utilize ladders for high jump and bricks for small jump, then this is the situation we can reach farthest possible index. Okay, so how we can utilize that into code? So think of like suppose for ladders it doesn't matter how how high jump is, right? How max diff between the next building and the current building, that doesn't matter, we can use the ladders. So how many jump we can make using ladders? How many jumps we can make using ladders? That is the number of ladders, right? Number of ladders. So this is definitely, if we can definitely say, we can make the jump, number of jump is equal to number of ladders. Okay, in case of we are using only ladders, because ladder doesn't depend on the difference between the height, we can use that. Okay, that the things we will utilize them. Okay, so if we have n ladders, then we can surely make a make n jump, right? N jumps. If we have n ladders, we can surely make n jumps. Okay, for n plus 1 jump, right? M plus 1 jump. If I take n plus 1 jump, then after, not n plus, let me generalize it. After n plus 1, we will required bricks, right? But think of, we will be using bricks optimally. Optimally means where the difference between the height will be minimum among all the jump. Like okay, so bricks will be required. So from n to, we will make a n plus 1 jump, from n to n plus 1 jump, right? I am taking that the threshold means up to n, we can surely like say we can make n jump, but we will making 1 to n, right? N plus 1 jump, one extra jump, to calculate which jump is the smaller, that we can replace with the bricks. Okay, so for n 1 to n plus 1 jumps, we will keep track of what we will keep track of, like difference. Uh, we will keep track of difference when we will making a jump 1 and jump 2, jump 3, similarly so on. Okay, so till n plus 1 jump. So if we have n ladders, we definitely take n jump, right? And once we have n plus 1 jump, we will need to like pop out what is the minimum one, right? What is the minimum among all these n plus 1 that I will where I will use the bricks, right? So that we can use the bricks for the optimal one, right? Optimal way where the we will use bricks for a smaller jump so that we can optimally used bricks and ladder for higher high jump. That the condition we will apply to reach the farthest possible building. Okay, so let me apply the formula for this one. Okay, so initially if you see, I will take what I uh, start from index equal to 0. Okay, and one things, if you see, I need among from n jump n plus 1 jump, I need smallest one, right? So what the structure that can give the smallest means smallest one, when we are insert adding or removing that, the if you remember that the priority queue, right? Min heap data structure that give the smallest one among all the uh, set of jumps. Okay, so priority queue by default it min heap, so I will use that. Okay, so let me start from iterate from this example so that you will understand better. So start from index 1, index 0, and start from index 1, right? So that I can compare. We can start from 0 or 1, be either uh, up to up to our decision, depend on the how you are comparing to I plus 1 to I minus 1 or I minus 1 to I plus 1, I to I plus 1. That's the things. So I am starting from I plus 1. So let's suppose uh, I plus 1. So I am assuming if possible I can reach I plus 1 or not. If we can reach, then how many breaks or ladders will be used, right? So let's initially we have two ladders, right? So we can make a jump, right? We can make jump up to 2. Okay, so let's take one jump and put into a priority queue. Let's define as a jumps. So once, why? Because I current index which is 1, which is height greater than the I minus 1 and difference is 8. Just put it here. Okay, and ladders we have 2 and bricks we have 0, not 0, 10, right? Initially for I is equal to 2, increment 1. Then for I is equal to 2, height is 2, which is the smaller than the I minus 1, which is 12. We don't need any jump. We don't need any ladders or bricks. We can just jump it. Okay, so just copy it here and paste again. I is equal to 3. Let me see if we can reach I is equal to 3. uh, okay, currently total jump I have taken so far is 1 jump, right? And we have ladders, total ladders 2. We can make another jump for reaching to the I is equal to 3, which is required the 7 minus 2. See that 7 minus 2, which is 5, right? So till now we have taken 2 jump, and I have reached to I is equal to 3, right? From 3, where the value is 7, uh, from I is equal to 4, which is 3 smaller height, then we don't need any jump. So I reach the I have reached the I is equal to 4, right? Which is the 3. Height is 3. Then reach again, go again, and once I increment I is equal to 5, then we have this diff, which is 15, right? So see that this have a 15. Once we have a 15 inserted into a 15, this is like we have made one extra jump respective of ladders, right? So via ladders, we can make only 2 jumps irrespective of irrespective of uh mac what what are the heights. Okay, so for this extra jump we will be like using bricks, but among all these 3 jumps we need to pop out the smallest one, which we will be using for the well, we will be replacing with the bricks. Okay, so let me just remove it, which is 5, and remove from means decrease from here, uh, so that will be 5. So if you see that 5, 7 minus 5, we will be replacing with the bricks. We have used 5 bricks here, and rest to jump we have used ladders. Okay, so let's go further. If you see that, let's go I is equal to 6, and we have still bricks 6. If you see 6, which is greater than the, let's put it diff, right? Once you put a diff which is 2, then if you check a condition, we have like total jump taken so far which is greater than the ladder, then we need to remove from the smallest one and replace with the bricks. Means replace means we will utilize the bricks for that smallest jump. Remove from here and put it here. Okay, not remove from here, and you use the 2 difference of 18 minus 20 minus 18, which is 2, will be filled by the bricks, and that I have subtracted here so that it become 3. So for I is equal to 7, let me just reach it. Let me see if we can reach I is equal to 7 or not. Yeah, we can reach I is equal to 7, and because it's smaller height, if you see 3 is smaller than the 20, so we don't need any bricks. If I is equal to 8, can be reach I is equal to 8. If you see there is difference is 16, right? Just put it here, 16. Then if you see, this is size of the total, means total jump we have taken so far is 3, which is greater than the total ladders. Then we need to pop out the smallest one, which is 8. But if you subtract from the bricks, that is the minus 5, right? Then in case of when we have like negative bricks, because we can't fulfill that height, then we just break and return the, which is the like I minus 1, which is the 7. That is the that is the building so far we can reach. Okay, so let me code it. Okay, so that you can understand. So what I need here, I need priority queue, right? I think I just need only priority queue, min priority, and this is integer type, integer. Let me name it as jumps, new priority queue. Okay, so I will start from I is equal to 1. Okay, as I said, for I less than, I will try to reach till last building if possible. So let me just length 5 plus plus. And as I said, first condition, I will check the height, right? From if the current height means I is the less than or equal to previous height, which is I minus 1. Just continue. We don't need any uh, jump. We don't need any like bricks or ladders. We can make jump easily without using bricks and ladders, right? If current height is greater than the previous building height, then we will require a jump, right? So I will just add into jumps that offer what I will required current height minus previous height. That the difference I will put here so that I will be using once we have used all the ladders. Okay. So if jumps dot size means number of jumps taken so far is greater than the ladders, right? So we will need to use the breaks. We will need to use breaks in this case. So let's pop out the smallest one, smallest jumps, smallest jump is the jumps dot uh, whole, right? That will give the smallest one, and breaks minus smallest jump. I will use the breaks for this smallest jump. If any case breaks is less than 0, means whatever the smallest jump can't be fulfilled by the breaks, then and we have already used, means this condition is satisfied, then we have already used the ladders, then we can't make any further jump, just break it, right? In last, I need to return I minus 1. Why I minus 1? Because I am starting from first index and try to reach that index. And this is where it will break. Means we can't able to reach the current index, but we have reached its previous index. So that's why it's I minus 1. Let's run it and check if its sample test case pass or not. Okay, so it's what is expected. Okay, that's syntax error. Okay, for the sample test cases, it got passed. Let me submit it and check if all test cases get accepted or not. Yeah, so that's accepted. So this is all about this problem. So I just wanted to like explain this problem because I feel this is little twisted and interesting one. That's why I have picked this problem. Yeah, that's it. Thank you. Happy coding.